going to talk about polynomial operations. And so this is going to be your first card. The first card is monomial, and it's a number variable or product of one or more variables, and the numbers have to have whole number exponents, okay? So take a look at the examples that need to go on the back of your card. An example would be 7, 2 times x to the 5th, and f times y times g. But important non-examples is 1 divided by g, because remember, if g is in the denominator, it has an exponent of, yes, that's right, -1. 4 times r to the -3rd, or notice 7 raised to the power of x. All of these are non-examples. Let's go ahead and make the screen larger now and move to the next slide. The degree of a monomial is the sum of the exponents of the variables in the term. The degree of a constant is 0 because remember the variable would be raised to the power of 0. So examples for the back of the card. 6, the degree of 6 is 0 because you could think of this as 6x raised to the 0 power. 6x to the 5th, the degree of course is 5. Now, look at this last example. It's a little bit tricky. 6x to the 5th, r to the 3rd, t to the 2nd. The way that you get this one is you look at the exponents. That's a 5, that's a 3, and that's a 2, and the sum of those exponents is 10. Now, those are monomials. A polynomial is a sum of monomials, or the monomial by itself. Each monomial in the polynomial is called a term. If you have a sum or difference of 2 monomials, that's called a binomial, and 3 terms, of course, is called a trinomial. So your example, 2x minus 6 is a polynomial, but a more specific classification would be a binomial. 6x squared plus 2x minus 7 is a polynomial, but this is classified as a trinomial. The degree of a polynomial. The degree of a polynomial is the greatest degree of its terms. Find the degree of each term, and the one with the greatest degree is the degree of the polynomial. Now, this does occasionally sound a little crazy, but this is the easy way to do it. Let's look at this first term right here on the back of your card. 2x raised to the power of 4, f raised to the power of 3. 4 plus 3 means this has a degree of 7. Now let's look at this next term. X is raised to the power of 2, f is raised to the power of 2, and g, of course, is raised to the power of, that's right, 1. And so this term has a degree of 5. Let's look at the final term. R to the 4th, h to the 1st, that's right. 4 plus 1 is 5. I look at all of these degrees, and the greatest degree is 7. So the degree of this polynomial is 7. Leading coefficient. When a polynomial is written in standard form, the lead coefficient is the numerical multiplier of the first term of the expression. Please notice the example. We are writing this in terms of x, and so when I look x to the 4th, then it goes x to the 2nd, and then of course it goes x to the 0 for the last term. Since 2x to the 4th, f to the 3rd is the leading term, the leading coefficient would be 2. And we often refer to this as lowercase a. Lowercase a usually denotes the leading coefficient. So, Mrs. Rose, you mentioned standard form. Why did you say that? Well, because we need to make sure that polynomials are written properly. One of my favorite movies is Hook, where Robin Williams plays Peter Pan. Dustin Hoffman plays Captain Hook. And sometimes when he talks to Peter, he talks about good form, Peter, or bad form, Peter. And in math, you always have to make sure, Peter, that you are in good form. So take a look at this polynomial, stop the video, and follow the directions. And let's see how you do. Did you look at the degrees? Which one has the greatest degree? That's right, 13x to the fifth. So it is rewritten as 13x to the fifth plus 12x to the third minus 15x. The greatest degree is 5, so the degree of the polynomial is 5, and the lead coefficient is 13. Okay, I have 6 problems here for you to do. I want you to write the polynomial so that the exponents decrease from left to right. Identify the degree and the leading coefficient of the polynomial. Go ahead and stop the tape, and go ahead and do these 6 problems. Welcome back. Did you get this for the first answer? I hope you did. Now, did you have to put parentheses surrounding negative 2x raised to the power of 2? No, but you know what? Again, Captain Hook says, good form, Peter, good form. Especially when you wrote the part where the lead coefficient is negative 2. It is very difficult for a teacher to tell when you have a negative sign with an equal sign. What about problem number 2? And problem number 3. Go ahead and make sure you bring problems 4, 5, and 6 into class tomorrow because that's how you're going to start your warm-up talking with your partners. Now, what's all this about polynomials? Let's talk about how to add polynomials. To find the sum of a polynomial, in this case, you have the quantity of 3x to the fourth minus 2x to the third plus 5x squared, and you're going to add that to the quantity of 7x squared plus 9x cubed minus 2x. Now, when I think of polynomials, I think of place value. And when you add things with place value, typical numbers like 10,343 plus 20,205, you tend to line things up in the place value format. That's what I'd like you to do for polynomials. With a vertical format, go ahead and list them like their place values. You would line up the x to the power of 3 underneath each other, the x to the power of 2, and then please realize that there are spaces left for where there is no place value. We don't typically write zeros. We wouldn't write 0x to the fourth, and we wouldn't write plus 0x. Just realize with the algebra, we typically don't do that. Hopefully you get the same answer as we did. Now, why don't you try this one? Subtracting polynomials. Subtracting polynomials works exactly the same, except I want you to remember about the first cards that we did on the first day of school about properties. Remember we talked about multiplying by -1. And on the card it said something to the effect of when you multiply by -1, the quantity becomes its inverse, okay? So I want you to remember that when you see a subtract sign. This says the quantity of 3x squared minus 9x, and then you are taking the difference of that quantity and the quantity of 2x squared minus 5x plus 6. We're still going to do the vertical format, but please look at what we do. When you line these up, just like place value, notice when you write the new quantity, you have taken the additive inverse. Think of this term as take the additive inverse, oh, sorry, lost an R, of. All right? So 3x squared minus 2x squared is x squared. Negative 9x, this becomes plus 5x, becomes negative 4x. And of course, what's here? A big old fat 0. Minus 6 is negative 6. Now, why don't you try it with this problem? Here's some guided practice lessons for you. Go ahead and stop the tape and write them down. This will be part of your warm-up for tomorrow. So my suggestion would be to go ahead and get them done tonight so that you can talk to your partners in group tomorrow. Final thoughts. Treat polynomial addition and subtraction just like you treated place value problems in elementary school. For those of you who are asking, yes, it really is that easy. Don't forget, you have a quiz on a word problem Wednesday this week for dimensional analysis. For more help on dimensional analysis, go ahead and copy this address and go see the virtual nerd, and they'll be happy to help you. Toodles for now. See you in class tomorrow.